Hi, I've just arrived from IBM Interconnect Las Vegas and I'm sitting here now in the IBM Spark Technology Center in San Francisco, and I'm enjoying a fantastic view all over the city. So today we have a special guest. His name is Berthold from IBM Almaden Research Lab, and he will present ApacheSystemML, which is a first-class citizen on Apache Spark. And the cool thing about it is that he has implemented some deep learning algorithms, and also he will show us how we can use the Python binding in order to interact with SystemML. So I think it will be a very interesting session, and yeah, so stay tuned and we will definitely learn really cool things from Berthold today.
Okay. There's actually one interview if you go to functional.tv. I gave one of those interviews with somebody else who runs some meetup, and I came to the meetup and then he said, okay, come over here now, I need to do an interview with you, and then all of a sudden we're in the midst of this interview. It's very similar to now.
So you are getting more and more famous, no?
Oh, that's only the second time. So.
Okay, so you've been the main act at my meetup and now I want to interview you. Okay, so I'm sitting here with Berthold. He's working for IBM Research Almaden, San Jose.
Yes.
And he was the main act at our data science and IoT meetup today in the Apache Spark Technology Center in San Francisco. So thanks for coming, and I think everybody was quite impressed. Initially they didn't get the point really, I thought, but then after you have explained everything so nicely, they really, I was seeing like, wow, like that. So tell us, what is SystemML?
So SystemML, it is a tool for data scientists to, number one, get them more productive, and number two is to enable them to run big data analytics. So run large-scale machine learning, including deep learning, on scale-out architectures such as Spark, large clusters, large data.
Okay. So how does it differ from MLlib and SparkML?
It differs from MLlib. MLlib is a library of machine learning algorithms with hard-coded runtime execution plans. Okay, so no matter whether you run MLlib on small data or on large data, it will always run the same jobs. Okay. While SystemML took a compiler-based approach, and during compilation it takes into account the data characteristics that you're about to run your algorithm over, and depending on what those data characteristics are, it compiles a different execution plan.
Okay. And you might have heard about Tungsten and Catalyst, and also SparkML runs on top of data frames and makes use of Tungsten and Catalyst. So how is the optimizer better or different than the one Spark brings?
Yes. Those are really complementary. Okay, so the SystemML optimizer, it really optimizes machine learning programs. Okay, and the operations within machine learning algorithms, they're really linear algebra based, okay, which is very different from like what Catalyst would do on a SQL AST, for instance. Some concepts are similar, okay, in terms of costing, plan enumeration, and so forth, and operator selections, but the core of it is very different. But in fact, we have ongoing research efforts on how to unify linear algebra and relational algebra into one compiler framework in order to benefit from it.
Okay.
Pretty cool.
That would allow me to run SQL statements within my SystemML code, or how shall I?
So that is very internal. Okay, it's engine level. How it would look like on the language bindings kind of level. We haven't really thought much about it.
Okay,
it is really about concepts such as in the SQL compiler, predicate pushdown and so forth. This concept is very well understood for SQL, but on the linear algebra, kind of it's the similar concepts, but kind of the execution on it is very different. Okay? And just detecting those concepts within that framework is very important. But you want to kind of bring both compiler frameworks together into one.
Okay. Yeah, I noticed a lot of similar terms. You have been talking about the optimizer, no? Like predicate rewriting and predicate pushdown and all that stuff. What else? Yeah, one advantage of SystemML, I think, is now that you have the Python binding. So that's new. I didn't know that.
Yes.
So
on it.
so how hard is the effort to create a binding for SystemML? To me, it seems not too hard because I think the API calls are quite limited. Is that
they
true?
are fairly limited. So it's a very simple API. We have bigger plans, and so because right now it's just a binding and the program itself, the machine learning. So it's the DML, which is the name of our language, actually declared as machine learning language. Within Python, it just looks like a string. Okay, so there's not really much integration there. And all the API does is take that string, binds the input and output variables, and execute it, and give me something to pull out the results. There's other efforts on the way, and actually we had ongoing intern projects on a Python DSL.
Okay.
So that's the DML is really written in Python syntax.
Okay.
So you would use like NumPy, nmod or those kind of operations. Okay, but the compiler would have to know that this one is actually an operation not on NumPy to be executed.
Yeah,
but eventually we kind of need to push it over to SystemML to get it done.
So you have to kind of patch the interpreter.
Exactly. So that's what we would call a Python DSL, domain-specific language. And actually, if you check out our website, there's a link to it. So there's a beginner. So we have an early prototype with some limited functions that we put into this DSL, but more work requires. So there's certainly always a low-hanging fruits, but the hard problems are really ones you need to want to push down control structures as well. So if you have a while loop in your Python, and if feasible, can you push down the entire while loop into SystemML? Okay, because if you run the while loop still in the Python interpreter and only the body, you go back to SystemML. Okay, you pay a certain overhead. Okay? If you can push the whole thing down at once, including the while loop, or other control structures such as ifs and else, then you're even better off.
That sounds to me like implementing a complete new interpreter which uses maybe the Python interpreter for some subtasks. No?
Yes. But there is precedent, so people are doing that not only for Python but also for Scala.
Okay.
Scala it might be even easier, and as well as for R.
Okay.
So actually, a few years ago we had a prototype for R, but we never went with it.
Okay. So one thing I wanted to ask, I just forgot it. It was just out of my mind. Give me 1 second. Yeah. So are you actually running against RDDs internally or against data frames?
So data frames are schema-tized RDDs. Okay, but in the engine level, it's RDDs. It's API level. We have data frames or data sets now in
and because if you would run against data frames, you would actually use Tungsten and Catalyst. So you are
and we do
bypassing that.
So similar demos that we've shown here with Python, because Python is just more popular with the data scientists. So similar demos we can show actually from Scala. So those notebooks that we've just seen, we can also demonstrate in Scala. The API is very similar there. Unless you use a Scala DSL, of which we have a prototype.
A lot of things going on.
Yeah, it's a very active project. We have a lot of really cool ideas. Sometimes you just have to be a little, you also have to deliver something.
That's true. Yeah, one thing you delivered basically was, that's also something which I learned today, is you have a solve function now.
Yes.
So how is that implemented?
Very good question. So this solve function that I've seen is a very let's say cheesy implementation, in the following sense that we only turn around and invoke solve within Apache Commons math. So it's only single node. It does not scale. And for the problem setting that we looked at for linear regression using direct solve, people say that you should not go beyond using that specific method of least squares formulation. You should not go beyond let's say 5,000 columns or so. Okay.
Okay.
So if it's up to 5,000 columns, our solve runs within one node, and the performance is kind of okay. Okay. But today we do not have yet, but we are working on a distributed solve as well.
So would that mean you would implement some sort of a batch gradient descent in that solve method, or?
So we would only do like a system, like a solve, like a pure solve, a batch gradient descent. No, we would not push that into solve. We would still keep that outside.
Okay.
It would just be a scalable solve. Okay.
Okay.
There's other methods as well. So not only solve, we also are looking into distributed like Koleski decomposition, Liu decomposition, and so forth. We have all those functions as well.
Okay. But
today it's only like the single node implementation of it, but we are working on distributed implementation as well.
Yeah, that's fair. No? You have to start somewhere.
Exactly, and for the use cases that we faced so far, it was just fine.
Okay.
Okay, so yeah.
Maybe another topic. I've now compared first-class citizen on Apache Spark, which is SystemML, against another first-class citizen, which is SparkML and MLlib.
Okay.
So how does it compare to TensorFlow?
Okay.
And there are maybe two dimensions. How runs TensorFlow on Spark? Is TensorFlow first-class citizen on Spark, yes or no? That's maybe the first question. And second, what are maybe the main differences between TensorFlow and SystemML?
Okay. So the first question, so if you only talk about TensorFlow as it is today, it is not using any data parallel platforms at all. So our goal was scale out needs to be provided by one of those data parallel systems, such as MapReduce or Spark. The decision for distributed TensorFlow was not to use any of those, but to use gRPCs for communication. Okay, and then they have a parameter server there eventually as well. Okay, so it's kind of a standalone kind of thing. They don't integrate. Although I'm sure there's efforts on the way to, if you look at TensorFrames, people talk about that package, which is basically every executor runs an isolated TensorFlow, like a single node TensorFlow.
What you could use, for example, for parallel hyperparameter tuning.
Yes. Yeah. So there is good use cases for it. Okay, and SystemML we are able to run those use cases as well.
Okay.
But it's and then there's other efforts on the way called TensorFlow on Spark, which I think will have a tight integration, but I have yet to look at the precise details of it.
Okay.
So I just went through the Spark Summit program, which will happen in June here in San Francisco, and Yahoo guys implemented this TensorFlow.
I have now a question where I'm absolutely no expert on, but I've seen in TensorFlow you can come up with a model, and then it automatically generates a cost function for you, where you can optimize over.
Yes.
Is that also possible in SystemML, or other plans for something like that?
We talked about it. Okay. We have not done anything about it yet. So they have this generic optimizer invocation for it. We talked about it, but we have not done anything to it yet.
Okay.
But in our neural network library, we have several popular optimizers in there, and you can just choose one of those. As for some parts, so maybe the second part to your prior question was another difference between SystemML and TensorFlow is that TensorFlow started off with deep learning.
Okay.
And it was only meant for deep learning. Okay, and now they are expanding that a little bit, I guess, to more generic machine learning as well. While, we came from machine learning from day one on. Okay, and now we are kind of putting deep learning into it. So that's another difference. Okay.
So you have made me really hot to use SystemML.
Good.
So I will really do my next experiments, which is the LSTM network for detecting anomalies in IoT sensor data streams on SystemML.
Excellent.
And I hope I can ping you and ask some
anytime
questions. That's
anytime.
Very nice.
Yes.
Thank you very much.
Okay, good.
Okay.
All right.
Bye. Thank you.